Hey guys, so this is a quick review of the free fall experiment that we perform in the mechanics lab at Qatar University. So this is the experimental setup. The aim of this experiment is to calculate the value of G. The actual value is of course 9.8 meters per second squared. You have to calculate your own value using this experimental setup. So experiment is straightforward. So you have a steel ball, okay, that you attach with this magnet. There's a magnet over here. The strength of the magnetic field is controlled by this screw, okay? And what you have to do is you have to measure the time that the ball takes to cover this distance, this vertical distance, and you'll measure the time using this counter over here. You'll take different vertical heights. You'll start with 20. So each of these patches is 10 centimeters. So right now it's 10, 20, 30, 40 centimeters. And these pointers over here, just to make sure that the ball and the sensor over here are at the right height, okay? So the sensor has to be in this position, okay? So that when the ball hits, the timer will give you the right time, okay? So let's measure, let's take a reading. So when you press this button over here, the ball gets released. So just let's make sure that this is at start, okay? And this mode should be at T sub E to F, okay? And now I think we're ready to release the ball, okay? You release the ball. You get, oh, for some reason we didn't get it reading. Let's do that again, okay? Let's do that again. There you go. There you go. Okay. Everything looks fine. Okay. Let's take a reading. Yeah. So we got it. Now it's 293.65 milliseconds. Okay. Now, so for every height, you will take 3 readings. Let's see what you have to do for the table. So you have, you'll take different values of height, okay, 20, 30, and you'll go up to 60. And for each height, you'll take 3 readings of time, and then take the average of that, and then divide delta x by t average, okay? You'll make sure that you convert this into meters, okay, so that you get your answer in SI units, okay? The units for this is meters per second. So let's look at the physics. The ball is a free-falling object. The equation for the height of the ball is delta y equals v naught yt minus half gt squared, right? So the ball is released with 0 initial velocity, so that you just get delta y equals negative h, which is equal to negative half gt squared. And why is delta y negative h? So let's say you release the ball, y equals 0. The ball hits at some point which is below the origin, so y final minus y initial is negative h. So that's going to be true even if you take your origin over here. Then you get 0 minus h, so it's the same. So delta y is negative h. So the equation for the ball is just h equals half gt squared. Now let's call h delta x because that's the notation that the manual uses. So the equation that you get is delta x equals half g experimental t squared. So you'll calculate this g experimental now. You will make a plot of delta x over t. You can just divide this equation by time so that we can plot a linear relationship. Delta x over t versus t, that's what you have to plot. And when you plot that, you get half of g as the slope. So the slope of this graph from Excel, take that slope and that's equal to half of g experimental, and twice the slope will be the experimental value of g from this experiment. So that was it for the experiment. Just one word of caution: when you attach this ball with the magnet, make sure that the magnet loosely holds it. Okay, make sure that the screw is not really tight. Otherwise, you get an error in the experiment. Okay. So that was it for the free fall experiment. Thank you for watching. Hope you liked the video.